Hello, we're going to be presenting revising environmental sustainability methods and how they affect engineering. The problem I wrote about was that I had to first explain what is sustainability. Basic definition is just ensuring that environmental, economic, or social systems will meet ours and future generations' needs at the same time, and while also balancing out natural resources. Environmental sustainability is centered on preventing climate change, reducing pollution, and minimizing the use of natural resources. So ensuring that sufficient fossil fuels are being used while making sure that the environment is still staying healthy. Examples of these sustainability methods include like natural forces like wind turbines, hydroelectric dams, geothermal systems, and another example is like designing cars that are energy efficient. It can make the car smaller or more reliable on gas. Recycling waste, just the white triangle with the green background. Then energy efficient designs such as LED lights, electric vehicles, or just basic small things in everyday life like scaled down appliances. How has sustainability affected engineering? Sustainability heavily affects engineering as it's a required standard across all industries, with practically all experts understanding that as a growing responsibility. The construction and engineering fields heavily contribute to engineering as they deal a lot um, with materials and waste at usually tons of material, and you have to ensure that you properly dispose waste and ensure that the energy is being used efficiently. Engineers have to already balance sustainability with factors like project deadlines, financial pressure, and workplace efficiency. So sustainability in general, it's a great thing, but engineers have to balance it out constantly in their workplace. They can get somewhat difficult. This video by Philippa Jeffers, she actually helped me a lot understanding and like sustainability engineering and first writing my proposal. She has like a few videos. This one's about I think 20 minutes long, but she basically sums up everything that I've learned so far. Like a current reform example is building model information. It's just modeling what a project is, what it looks like. These models can be 3D or 2D, and they're digital. And they tell workers the life cycle, design, and energy usage of the project they're currently working on. So not only does this improve, communication, but also makes sure that their ideas and current progress are always written down. It also allows them to like locate weaknesses in a project and make sure that they know what the correct next steps are, especially with efficiency and making sure that they are not wasting any material. Um, BIM also minimizes waste, improves energy efficiency, and supports collaboration between workers and stakeholders, as anyone with access will understand what is going on the project, and this allows communication on the field and in the offices that control the workforce. But BIM requires education and training that not all engineers will have. Sometimes engineers are either inexperienced or brand new, and a lot of these things are not taught in the classes that they brought. Four-year colleges, they might not have a class for you to understand BIM. And for example, my dad, he's an electrician. He uses stuff all the time, and he had to, no one taught him this. He had to learn it with just experience. So BIM is very helpful. However, not everyone can use it. Another reform is engineers trying to convey that sustainability has many long-term benefits, which is true. They advocate for the overall project value being increased, and as well as improving efficiency and reducing waste. And there's still many out there reluctant to fully lean into sustainability as The upfront cost and the unreliable financial return is sometimes seen by business owners or stakeholders. Scheduling pressures also caused by sustainability can create reduced labor, higher error rates, and disruptions in order. That ties back into how sustainability makes engineers balance all the already existing factors and sometimes makes it a lot more confusing. Sustainability processes can hold back jobs a lot of times as they have to follow policies and certain requirements for their job. Claudia Eckert explained this in the TED Talk. She was great, and she really just showed why sustainability is beneficial. However, she did not really gloss over the problems with it or the problems shown by engineers. So some goals for sustainability and my current proposal is that we need a technology that would improve workplace communication and the decision-making and design efficiency of workers. Lots of times, sustainability is not properly integrated with their workplace decisions and either is maybe forgotten or not put emphasis on currently, and it needs to be accessible in a way we can do that. Such as solving complexities or all of the extra time it takes on a workplace. Lots of times, sustainability systems are put because of the inexperience of the workers or the new systems. As sustainability grows, it makes more complex situations for workers. You can also improve the organizational aspects of BIM. Not only include models, but make sure you're including data and, if there's a 3D model of a building, it could include what parts of that building had however many materials into it and how much, you know, gasoline or whatever fuel they're using it took to build that part of the building or sustain that part of the building. And this isn't just for buildings either. It can apply to any industry of engineering. And you also have to prove that sustainability will benefit specific projects using their own workplace data. The project owners must have to know that the sustainability method is currently benefiting them. My solution is that engineers have to mainly balance environmental impacts with already existing cost deadlines and design efficiency, which not only creates a longer decision-making pressure, but also limits the ability to practice sustainability. To solve this issue, an accessible system that reduces complexity is required. My solution is to develop a digital, sustainable decision-making platform that will allow engineers to evaluate environmental, economic, and structural impacts of a system or impacts of a sustainable system within a single system. So the first step in completing the solution is hiring software engineers that will be required to develop this platform. They specialize in digital platform coding statistics that regular engineers could not create. Not regular engineers, but other unspecialized engineers. Engineers that deal with sustainability, especially those in construction, civic engineering, or architectural or mechanical, they'd be allowed to collaborate with these software engineers, make sure that they're going in the right steps to understand what they really need on the workplace. Environmental and engineering data would be used just to make sure that materials, energy use, and long-term impacts are being recorded. Integrating the platform into engineering workplaces is essential. You need to make sure that this technology is being used on the workplaces. It would have to be used from the start to the end to ensure that everything is recorded and to make sure that the platform will be utilized correctly. And of course, no artificial intelligence is going to be used, as I doubt project holders or stakeholders will be pleased to hear that their business is being put onto an AI. Engineers will also be given proper training to make sure that they can utilize the platform, make sure they know what kind of data they are putting in and how to use the decisions that are being put out. And then maintaining the platform and using feedback The platform will be regularly examined to make sure that it's benefiting the workplace while also giving out correct decisions. It would analyze the cost efficiency, environmental impacts, and the workflow improvements within the environment. Engineers will also be encouraged to provide feedback so software teams know what they can do to improve it or change, and accuracy and usability will be emphasized, along with the overarching goal of avoiding sustainability denial and making sure that they're not treating sustainability as just like an add-on. Feasibility. Many sustainability-focused digital systems have been funded and implemented. BIM has some sustainable aspects. Uh, Engineering organizations and stockholders must be sold onto the fact that this platform will help their business. It will create long-term benefits that may not seem evident in the beginning, but they will show later on. The United Nations Environmental Program, they emphasize that achieving sustainability requires very big changes in the way that traditional engineering is worked out. Because this digital tool is designed specifically reducing waste, it actually meets the interest of both private industries and the public environmental priorities that are being carried out, along with the actual engineering workers, as this makes their jobs much easier. Sustainability in engineering has created significant problems or issues or just complexities, but it's still always and will be increasingly important for our society. With this proposed platform, sustainability will be more approachable and understandable for workers and engineers currently working on projects. And those involved in engineering industries have to understand that this platform could be essential for the future of sustainability as it becomes increasingly required as sustainability requirements grow. Thank you for presenting. Thank you for listening.